based on the details we got from the abundant girder there. The superstructure, the longitudinal girders were stressed with 12-5-5 cable at that time, which consists of 12 HT steel wires, 5 mm dia arranged around a helic 3 mm dia bar, and it is sheathed in 32 gauge steel sheet pipe. Each girder is stressed with each outer girder is stressed with 24 number of such cables, and inner girder was stressed with 23 number of cables. This was the sheathing arrangement from the Freycinet system, which was used at that time in the bridge. The cast steel rocker and roller bearings were provided in the 14 spans, and there's a lead sheet bearing which was provided in the balance 8 spans. And 1.7 meter long gap slab is provided between the 2 adjacent spans. And angle plate type expansion joint is installed. This is the photograph showing the bearing position of existing bridge before rehabilitation. The broad scheme of rehabilitation was divided into the 3 parts. The phase 1 consists of the condition survey and inspection of existing bridge. In the phase 2, we performed the analysis of the structure considering the de-stress condition, and we designed the scheme for strengthening, repair, and rehabilitation based on the report of condition survey and inspection. And third phase was the actual execution of strengthening scheme at site. Inspection and investigation de-stress. This was given to a specialized agency to perform to prepare a complete report of investigation, and the inspection and investigation is done by visual inspection of the bridge. Then non-destructive tests such as rebound hammer test, ultrasonic pulse velocity, etc. tests were performed to check the concrete strength, and chemical analysis was done for the chloride and sulfate contents in the existing concrete. And the level of pre-stress was also done by a test called core trepanning test, which is developed by the Structural Engineering Research Institute. Mr. G.S. Tonk will explain this in detail later on. A gantry was installed over the bridge for the inspection of bridge, because the height of piers of the bridge is about 15 to 16 meters. So it was not easy to access it from the ground, and moreover, water remains in the river. So therefore, it was decided to prepare a gantry for the inspection. And the purpose of inspection was to assess the condition of various components, to get the geometric details, to map the cracks, and to map the de-stress in the concrete, and to note if any other de-stress such as damage or displacement, etc. has occurred in the existing bridge. This is the scheme of testing. Total 88 girders were there in the bridge which were tested, and the testing was also done on the diaphragm and deck slab. Critical locations in the girder like mid-span and near the supports were tested, and rebound hammer test with 9 grid system as per standards were used for 12 locations in each span. Then ultrasonic pulse velocity test, half cell penetrometer test were done near the same location. Core cutting was done at 2 points in each girder. In situ stress measurement was done on the 3 spans by trepanning, and the laboratory tests were also done. These are some photographs of the actual during the testing at site and in lab. The observations were, there were longitudinal cracks were observed in the bottom bulb of the girder and the cross girder. The vertical cracks of 0.1 and 0.15 mm thick at the center of girder were also observed. All the bearings were found to be badly rusted, and the gap slab and expansion joint, etc. were all damaged, including the railing, etc.